Hi, and welcome to Chapter 8. But before we talk about Chapter 8, which is basically talking about how taxes can either hurt or harm the economy, we need to first go back to Chapter 6 and remember exactly what taxes do to the economy. So remember it. The right way to analyze it is we drive a wedge between the price buyers pay and the price sellers receive, and the quantity bought and sold is reduced. And this is important. We're not really going to worry about who's getting charged the tax because, remember, the outcome was the same no matter who was charged the tax. Okay, so let's go ahead and throw up a supply and demand curve. This is the old equilibrium and quantity with no tax. We're going to call this PE and QE. All right, now let's put in a size tax of $T per unit. And remember, the appropriate way to do analysis for tax is just slide in a line that's $T tall, and once it hits, then we know that this is the new equilibrium. Okay, buyers pay PB, sellers receive PS, and the quantity that is in the transaction is QT. I'm going to call that QT for Q with taxes. You see the quantity has fallen. Okay. The amount the government gets, as I mentioned back in Chapter 6, is this box here. They're getting $T per unit. They're getting times QT units, so they're getting the area of this rectangle right here. All right. But now let's go ahead and use our new tools of welfare economics, consumer surplus and producer surplus, to see who, if we're better off or worse off with or without the tax. It's important to note that, okay, actually, let's calculate before the tax happens. We have this consumer surplus, A, B, and C all together. We have this producer surplus, D, E, and F. This is exactly like we learned about in Chapter 7. But now let's throw in this new idea, the tax, okay? All right, so with the tax, I'm going to throw in a tax wedge of T. Just remember, like we did on the previous slide, and the price the buyer pays is up here at PB. So remember, as the price raises from, this was PE right here, this is PE. As the price raises from PE to PB, consumer surplus decreases. Now it's just A, producer surplus is just F. The tax revenue is B plus D, okay? And so the way to think about this is this whole area here is still good things that are happening. This is the happiness to the people. This right here is the profit from the producer. This rectangle right here is tax money that's paid to the government. But in this model, we're just saying that taxes are used from the government to build nice things such as schools and roads. So this money that's paid to the government is not lost. But I want you to see something that is lost. C plus E. You see, that used to be in the old the old total surplus. The old total surplus was this giant triangle right here. But now the new surplus is this amount right here. So we're missing out on C plus E. Now there's no story we can tell. Like B and D, we're okay with this going away because the government gets it and it purchases roads and schools for us. But C and E is lost, and it's lost forever. And so therefore we call it the deadweight loss. It's basically just a waste, and this happened from the tax. It was created from the imposition of the tax. If the tax was removed, the quantity would go back to QE and the deadweight loss would disappear. All right? And the reason why it happens is because QT to QE is not being sold. There are people here, guy number QT, this guy right here, number QT plus 1, QT plus 2, all the way up here, all the way up to QE, who want to buy but cannot because of the new expensive price. All right? So the tax prevents some trades that we actually want to happen. So let's analyze this real quick. Compute these things that I asked for, and then put a tax on it. Okay? So when you're done with that, I'll give you the answer. All right, so in the beginning, the consumer surplus is 10,000, the producer surplus is 10,000. That's pretty simple. Okay, total surplus 20,000. Let's throw a tax wedge in there. So remember, something that's $100 tall, we're going to slide it in there. So now we have a new equilibrium. The tax equilibrium, an equilibrium has to include prices and quantities. So we have 250, 150, and 75 is our new equilibrium. Our consumer surplus is now decreases to 5,625. Our producer surplus also decreases, but some of this money goes to the government, which is fine because they build convenient things for us. But so that's the total surplus. But the big problem is this deadweight loss, okay? And I want you to go ahead and calculate this using the same triangle formula. This is the base. You can use that as a base, and you can use this as the height. These are both easy to find, 250 to 150, that's the base. And 75 to 100 is the height. You can think of it as a triangle that's been tipped over. It's 1,250. All right, so what determines the size of this deadweight loss? So if there's perhaps goods with small deadweight losses, we should tax them. How can we find out the size of the deadweight loss? Well, it actually depends on the price elasticities. So remember price elasticities, we learned these in chapter 5. Okay, it's how much quantity changes when price changes. And we represent it with the slope of our demand and supply curves. Okay, so here is a supply curve that's straight up and down that's known as inelastic. And let's throw the tax wedge in there. We have a deadweight loss that looks like this, okay? So the tax reduces quantity a little bit and deadweight loss is small, right? Because remember, this is our tax wedge we slide in there. This right here is PB. This right here is PS. This is producer surplus. This is consumer surplus. This is government revenue. And this right here is the deadweight loss. You see it's pretty small when we have an inelastic supply, okay? What happens if supply becomes more elastic? We're going to slide in that same tax wedge, okay? This is the same height, but notice the Q decreases more, and therefore the deadweight loss is much bigger, okay? So if we have elastic supply, a very flat supply curve, the tax makes a very big deadweight loss. All right, now let's think about demand. We're going to find the exact same things with demand. If we have an inelastic, that means an almost straight up and down demand curve, we slide the tax in there, the deadweight loss is small. But if the demand curve is quite flat, meaning it's very elastic, look what happens. The deadweight loss is very great. Remember, this right here is the price the buyers pay. This right here is the price the sellers pay. This is deadweight loss. Mutually beneficial gains that are lost because trade is prevented by the tax. All right, so let's look at the size of the deadweight loss and let's think about it. Tell me if it would be bigger if the tax were on these three, which of these three choices? Now, in order to answer this, you're going to have to think back to which one of these have larger elasticities. Remember, larger elasticity means larger deadweight loss. Okay. Which one of these has a larger elasticity? Well, from chapter 5, we know that breakfast cereal is more price elastic. So we do not want to tax breakfast cereal because it has a large deadweight loss. We do want to tax sunscreen. If we need to tax a good, we should tax sunscreen because the deadweight loss is much smaller. Same thing right here. Short run or long run? Do you remember? Long run has higher price elasticity. So we want to tax, if we need to tax a good, we should tax hotel rooms only in the short run. And finally, groceries or meals at fancy restaurants. Groceries are less elastic. Meals at fancy restaurants are luxuries. They are more elastic, so we should tax groceries in order to make a smaller deadweight loss. All right, so here's a question. Should the government tax groceries or meals at fancy restaurants? I seem to sort of indicate that with the previous slide, but how would you answer that question? All right, let's ask this question. How much should the government tax, or how big should the government be? So the problem with a big government is it requires big taxes, which means big deadweight losses. And so the the argument for a small government or a small amount of taxation is this deadweight loss argument. The labor income is the biggest source of government revenue, so we really should think about how much is the deadweight loss from taxing labor income, okay? So it depends on elasticity. We'll show it right here. If labor supply is inelastic, that means the supply of labor, the deadweight loss is small, obviously. We know that inelastic means small deadweight loss. Large elasticity means large deadweight loss. All right? So many people, some economists, believe labor supply is inelastic, meaning that most people work for full time no matter what the wage is. Okay? Other economists, however, believe that the supply is elastic and therefore labor taxes create a high deadweight loss. That's what this means right here. Highly distorting means it creates a large deadweight loss. And the argument for an elastic labor supply is that many workers can adjust their hours, many families have two earners, and many elderly people choose to retire based on the wage they earn. Okay? And then finally, a lot of people drop out of the regular economy and work, quote, under the table, meaning they get cash, so they don't have to pay taxes. So labor supply might be elastic, in which case the deadweight loss is very large from this. All right? So it's unknown which of those is true. Policymakers often change taxes. What happens if there is a tax and then there's a tax change? How does that change deadweight loss? Well, you should be able to understand this pretty easily using our supply and demand curve. Let's suppose the tax is $T, okay? So we're already having a tax. The tax wedge is $T tall. We slide it into there. Well, the deadweight loss is that big. But now suppose that we double the tax, and so the tax is $2T. So we slide in the 2T, and it hits right there, and we see the deadweight loss gets bigger. It's actually much more than doubling. And if I triple the tax, the deadweight loss is very big, more than triple. So if I think about it with a graph, as the tax size increases, the deadweight loss starts getting huge. You see this is not a straight line. This is not a straight line like this. This is something that increases, and it will start increasing at a large rate the more taxes that are asked, or the more taxes that are charged. Okay? So let's think about how much revenue the government gets. Now recall, this rectangle right here is the amount of money the government gets because they get $T per thing sold, and there's Q of them sold, so they get the area of this rectangle. And if you, when the tax is small, if you increase the tax, the tax rectangle, the revenue rectangle, also gets big. But what happens if you increase the tax too much? You see, this tax rectangle starts getting smaller. So if I were to graph it, it looks like something like this. As the tax starts getting bigger, more and more money is accrued to the government, right? As that rectangle gets bigger. But then as we get to here, the rectangle gets smaller and smaller and smaller, and this is the size of the tax. So as tax gets smaller, as tax gets bigger, revenue starts going back down. So the government, really what they want to do is they want to try to have this tax right here that maximizes their revenue, okay? And basically the question is out there, do you think that right now we're on this side, or do you think we're on this side? And that's going to lead to different things, because if our current tax rate is up here somewhere, we should definitely lower the taxes. If our tax rate is here, we could raise the taxes to get more government revenue. Unfortunately, we don't really know where we are on the Laffer curve.